Hi folks, so this is question 9. So Alex gets injections of a drug, so each injection has 15 megs of the drug each day. So what this little formula here means is uh, it's how much is left in his system. So if you want to know after 1 day how much of it is left in the system, you just sub in a 1 instead of the t. If you want to know after 3 days how much of the drug is left in the system, you sub in a 3 and so on. So it decreases by 40%. So the first part just asks you find the amount of drug in Alex's body 2.5 days after a single injection. So we just, to work out for 2.5 days, you just have to sub it in. So 15 times 0.6 to the power of 2.5, and then you just put it into your calculator, and you should get 4.18. So that's easy enough. The first part, you're just putting 2.5 in instead of t. So t is the number of days. How long after a single injection will there be exactly one megs of the drug left in his body? So we're looking for when the answer is 1, basically. So when will 1 be equal to the formula? So 15 times 0.6 to the power of t, and we're trying to find out t basically. So we can bring over the 15, so it's 1 over 15 equals 0.6 to the power of t. And then when working out a power, we always use logs, so we can use the natural log. Ln 1 over 15 is equal to ln 0.6 to the power of t, and that allows us to bring the t down then, so we can bring t in front of the ln 0.6. And then we can just bring over that to the other side, so t will equal natural log of 1 over 15 over of 0.6. And then you can just use calculator for that from there, so you should get 5.3 if you sub it in. So that'll be days then, so you've worked out what t is. So t is the time, t is in days, so and that's rounded off to 1 decimal place as well. Right, so the third part then, so Alex is given a 15 megs injection of the drug at the same time every day for a long period of time. Explain why the total amount of the drug in megs is Alex's body immediately after the 4th injection is given. So he's given an injection every day then. So what's going on here is that if that was the first day, well, there's just 15 in his body then after the first injection, and then the next one, that'll be the second day. So you could write in something like that, so first day, second, third, fourth. So this is how much is left in his body from back the first injection, really. So I may actually change that the way I'm phrasing it. So if you think of the 15 there as today, and then this is 1 day ago, so 1 day ago, then that's 2 days ago, and then this is 3 days ago. So this term here is 3 days ago. So if you think about it, this has to be how much is left in his body from that injection. So that's one injection there, and that's that he got 3 days ago. So if he got that injection, if he got 15 in his body 3 days ago, well then it would have to be 15 times by 0.6 times by 0.6 times by 0.6, because it decreases by 0, because there's 0.6 amount left after each day, basically, because it's 0.4 gone just because it decreases by 40%. So that's and you could write that in then, maybe how much is left in his body from the injection 3 days ago. From 3 days ago, and then you could write in the same then for this one. So this would be how much is left in his body after the injection from 2 days ago, and then this is how much is left in his body from the injection yesterday or one day ago, and then this is how much is in his body from the injection just now or just today. So you could write in little something like that with each of those, or you could kind of explain all that in English in just sentences, so it's up to you. So the question just asks to explain it, really. So that's the logic behind it. Part D, find the total amount of the drug in Alex's body immediately after the 10th injection. Give your answer in megs correct to 2, or milligrams correct to 2 decimal places. Right, so if we're thinking for the 10th injection then, so on the first day there'd be 15 in his body, and then on the second day, so if we're kind of following the formula from before, it's 15 times 0.6 to the power of 1, and then, so that's the second day then, and then the third day it'd be 15 times 0.6 to the power of 2, and then that's going to keep going all the way up then until the 10th day. So the 10th day would actually be 15 times 0.6 to the power of 9. It won't be 10 because that's day 1 there. Here that's day 1, day 2, day 3. So if you think about it, the n or the power part is always 1 less, so that's the 10th day then here. So it's a sequence really, and it's a geometric sequence, so you can just use the formula for sum of a geometric sequence, and that is S of n so S of n equals a 1 minus r to the power of n all over 1 minus r. So in this case then a will be the first term, so that's 15, and r will be what it's being multiplied by each time, so that's 0.6. So if you just sub it into the formula, then you get 15 times 1 minus 0.6, and then the n here, you just have to be careful, it's going to be 10, because we want it for we want the 10th term. We want the sum of the first 10 terms. We don't want the sum of just the first 9, even though the power there is 9 at the end. We want the sum of the first 10 terms, and the 10th term is that 15 times 0.6 to the power of 9. So we want it for 10 terms, and it's all over 1 minus 0.6 then. And then it's just calculator work again. You can put it in, and you should get 37.27 mg, so milligrams or megs. And that's rounded off to 2 decimal places as well. So part E then, use the formula. So it tells you to use the formula for the sum to infinity. So s to infinity is a, so go to your log tables again, over 1 minus r, so nice and simple. So you just have to use the same things from the last part. So a is 15 and 1 is 1 minus r is 0.6. And then if you just use calculator again, you get 37.5. That's a nice simple little part. Now here then, it's the same type of thing that's going on, it's just the kind of parts are different. This time it decreases by 15%. So if it decreases by 15% for Jessica, then there has to be 0.85 left each time. So that's going to be how much we multiply this time. It's going to be a sequence pretty much the same as the last time. So she also, so just reading through the question again, she also gets daily injections every day. She gets D milligrams or mg of the drug in each injection. So she gets D, so it only tells us D. We don't know. The last time at the start of the question we were told that that person got 15 in each injection. Now we're just told that she got D. Okay. And that's all the information we really have. So you can kind of write it out as a sequence again. So she gets D in the first one, and then so this is what it's going to be, D plus D times 0.85, and that would be kind of after day 1 then, and then D times 0.85 to the power of 2, and so on, all up to the power of n minus 1 again. So it's exactly the same really, it's just that the parts are different. We've a 15 instead of, or we've a D instead of a 15, and we've 0.85 instead of a 0.6 like before, because it decreases by 15% this time, but it still forms a geometric sequence like that. And then it just says use the sum of geometric sequence to show that the total amount of the drug in your system immediately after n injection. So we just need to use the formula again for Sn, so for the sum. So Sn equals D times 1 minus, so D will be the A part in the formula, so A is D. It might be a bit confusing, but the A from your log tables will be D in this case because we start out with D, and then R has to be 0.85, so D times 1 minus 0.85 to the power of n over 1 minus 0.85. Okay. So we filled it in, and we should be pretty close to getting this now. So we're actually almost there, but we just need our answer to look like what that is in the red box. So let's just simplify it first. You can just subtract the bottom bit. So D times 1 minus 0.85 to the power of n over 1 minus 0.85 is 0.15. Now we've got to do one little trick here to make it look like what's in that red box. So if you look there, there's a 20 in front of the D, so that's a clue. And in our one, we only have a D. So how would we change D there into 20D? What you need to do is you need to multiply it by 20. So what we're going to actually do is multiply by 20 over 20. So multiplying by 20 over 20 is the same thing as just multiplying by 1, because 20 over 20 is just 1. So that's the trick here. We're not actually changing the fraction, and we're not really multiplying the fraction by anything. we're just multiplying it by 1, but we're changing the form of it because we're multiplying by 20 over 20. So that then would give us 20d times 1 minus 0.85 to the power of n. The n should be inside. All over, and if we multiply the bottom there by 20, if you do 0.15 times 20, it actually gives us 3. It gives us what we want there from the box up here. So we've shown that we've changed it, we've put it into that form. So that's that part done. Immediately after the 7th injection, then there are 50 megs of the drug in her body. So find the amount of the drug in one of Jessica's daily injections. Right, so all we're going to do here really is we're going to let 50 be equal to that when n is 7. So the 50 equals 20d times 1 minus 0.85 to the power of 7, 7th injection, over 3. So if we bring over the 3 first, we get 150 equals 20d 1 minus 0.85 to the power of 7. And then we can bring over the 20 and we can bring over the 1 minus 0.85 to the power of 7 together, so we get 150 over 20 times 1 minus 0.85 to the power of 7. And then you can just use calculator from there, and that should give us d. And if you put all that in, you should get 11 when you round it off. So 11 mg, 11 megs or milligrams. So that's it. That's all of that question then.